Okay, so as requested, I'm going to go over a few questions that students had issues with today in class. So one of those questions was number 11. Number 11 says, AB is tangent to circle O at A, not drawn to scale, find the length of the radius R to the nearest tenth. Okay, so the first thing I want to point out is that from A to O is radius. That means from there to there, that's also a radius. I'm going to put a little r right here. Okay. Now, because it tells us that AB is tangent to this circle, tangent line, that means that the radius and the tangent line are perpendicular, which means we have a right triangle created here. Whenever you have right triangles, you can use the Pythagorean theorem. Okay, so let's do that. I'm going to call this A, this is going to be B, and this is going to be C. But with C, you have to take into account that the whole thing is C, so that's going to be R plus 3. Okay, so we set that up. It's going to be R squared plus 8 squared equals R plus 3, all in parentheses squared. So if we have this, let's do the algebra. Oops, didn't mean to do that. We have R squared plus 8 squared, which is 64, equals R plus 3 times R plus 3. Okay, now when we distribute this, you're going to do your first terms, which is R times R. That's going to be R squared. And then you're going to have R times 3, which is just 3R. Okay, so we've distributed the R. Now we need to distribute the 3. 3 times R is 3R. 3 times 3 is 9. Okay, so we've got all that we need here. R squared plus 64 equals R squared plus 3R plus 3R plus 9. We can combine those. It's going to give you R squared plus 6R plus 9. Over here we still have R squared plus 64. Okay, now we're going to subtract R squared on both sides. It's going to cancel out. So now you have 64 equals 6R plus 9. Subtract 9 on both sides, you get 55 equals 6R. Divide by 6 on both sides, and you end up getting R is 9.2. Okay. Next, some people requested number 12. So if we look at this question, it says the circle is circumscribed by the pentagon as shown. Okay, so I want to go over something quickly before we do this problem. Whenever you have a circle and you have two tangent lines, Jordan, hold on. so whenever you have two tangent lines, if they are both tangent to the circle, they're both tangent, then they are congruent. So let's say this is x, y, this was z, y. Whatever it is, these two lines are tangent. So that means these two lines are congruent. Okay, so that's what's happening all the way around this pentagon. We've got several tangent lines. Okay, so the circle is circumscribed by the pentagon as shown. QZ is 8. That means QR is also 8. YX is 9. So YZ is also 9. XY is 11. Sorry, not XY. XW is 11. And then that means that VW is also 11. And it says UW is 19. So if that whole thing is 19, that means this has to be 8, and this has to be 8. And it says SU is 12. Okay, so then that means ST is 4, and SR is also 4. So when you add up the perimeter all the way around for the pentagon, you end up getting 80. Okay. Okay, let me see what was the other questions today. 11, 12, 21, and 22. Okay, so 21. It's going to be all the way down here. Okay, so 21. Sorry, my son being kind of loud. Find FC and circle P. Okay, so this FC is going to be right there. So basically, whenever you have, let me step back for a minute. Whenever you have a circle, the diameter and a chord, when the diameter goes through any chord in the circle, it's going to bisect it. It's going to create a 90-degree angle. Okay, so as long as you have that 90-degree angle, the chord is bisected. So that means that if the chord is bisected, these two pieces here, hold on, let me get my pen ready. Those two pieces there are the same. Okay. Another theorem going on here is when you have two chords, sorry, my drawing is pitiful. If you have two chords that are the same distance to the center of the circle, then those chords are congruent. So these two chords are congruent because they are the same distance to the center. Okay, so we look at our problem 21, we've got those two situations here. We have two chords that are the same distance to the center of the circle. Okay, so you know that they are the same length, and then you have this diameter that is creating this 90-degree angle on both of these. So that means it's bisecting those chords, therefore cutting them in half. So if half is 4, so is the other half. Same thing up here because they're the same distance to the center of the circle. They're the same length. So FC is 4. Okay. Number 22 was another popularly requested question today. So I want to notice that CP is also a radius. That's going to be 6 as well. PE is also a radius. The whole thing's going to be 6. And it gives you FE is 2. So that is 2. And so the whole thing's got to be 4 from P to E the PE has to be 6. So this piece here has to be 4 because 4 and 2 make 6. The whole thing has to be 6. Okay, and then this was kind of the abstract part. I'm going to draw in another radius. Okay, I know the radius is 6. Okay. Because those are vertical angles, this is a 90-degree angle as well. It's asking you to find AF. So I'm going to make an X there, and that is a right triangle. So you can set up the Pythagorean theorem. You can say x squared plus 4 squared equals 6 squared. We have x squared plus 16 equals 36. Subtract 16. You get x squared is 20. Take the square root. You get x is 2 on the square root of 5, or 4.47. Okay. Let's see what our next page is. See what some other questions you have. Okay, looks like 29. I had a lot of people ask me about 31 today in class, so let's do 31. On 29, it's asking you to find the measure of angle 1. And then this is an inscribed angle, and this is its intercepted arc. The relationship there is the arc is double whatever the angle is. In this case, our angle is 66. So the arc is 132. Okay. Now that you know that, we can find this other arc, which is the rest of the circle, by saying, what is 360 minus 132? Well, that's going to give you 288. That gives you that red area right there. Okay, this is what we call an outie. Whenever you were trying to find an outie, so we have a circle. What was this? This looks like 2 tangent lines. Okay. So we have 2 tangent lines like that. The angle let's call this angle 1 equals so I'm going to label this a little bit better. Let's do okay, so I've made up some numbers here. To find that angle 1 here, what you have to do is you have to take the measure of the measure of angle 1 equals the outside arc minus the inside arc divided by 2. So in this case, the measure of angle 1 is going to be 210, that's the outside arc, minus 150 divided by 2. So this is going to be 6. The measure of angle 1 is going to be 60 divided by 2, which is just 30. Okay, so in this case, the measure of angle 1 is going to be 288 minus 132 over 2. That's going to give you 48. On this next question, number 31, you had to see that this, this 142 angle and this other angle make a linear pair. So to figure out that other angle, it's 180 minus 142. That's going to give you 38. So this angle is 38 degrees. Right? Now this becomes an any. For an any, that inside angle, whatever it is, in this case it's 38, equals the sum of the opposite arcs. The sum of the opposite arcs is going to be x plus 69. And then all of that multiplied by 1/2, or we can say divided by 2. To undo that division, we're going to multiply by 2. So 2 times 38 gives you 76. That's going to undo itself. So then we have x plus 69. Subtract 69. You get 7. Okay. On this next question, 35, I've highlighted 2 chords that I want to look at. So now we are looking at segments that are inside the circle. So that's either going to be part times part or outside times the whole thing. So when we look at these 2 chords and we are doing part times part or section times section, and I've already filled in pink what the question gives you for these 2 chords. So part times part for chord ED is going to be x times 14. For chord AB, part times part, well, this is all one part. So 3 and 5 makes 8. 7 would be the other part. So that's going to be 14x. So you need to kind of ignore this other chord, CD. I wonder if I can color that in. If it'll let me. I don't know. We'll see. Yeah. So we kind of need to ignore that other chord right here. Just focus on what I have in blue. So when you do part times part on this one, one whole part is 8. The 3 and the 5 make 8. And then the other part is 7. So that's how I got the 8 times 7. 8 times 7 is 56. Divide by 14 on both sides. You get x is 4. Okay, so I'm going to erase my picture and look at some other pieces. So now, let's see what color we're going to use. Let's use red. So now I want to look at these two chords. And let's kind of cover up the other one. We don't need it right now. Okay. It says AP is 3. It says PQ is 5. It says QB is 7. CP is 2. And EQ, that's what we're trying to find. We need to find a PD, so I'm going to call that Y. Okay. So part times part is going to be 3 times 5 plus 7. What's 5 plus 7? It's going to be 12. So 3 times 12 equals 2 times Y, because that's the other part times part. 3 times 12 should give you 36. 2 times Y is 2Y, divide by 2. 18 is your Y. So PD was 18. EQ is 4. Okay. The last question, I'll help you set up number 37. I won't go through the algebra, but I'll help you set it up. Basically, whenever you have a circumscribed quadrilateral inside a triangle, not a triangle, sorry, inside a circle, whenever you have a quadrilateral inside a circle, opposite angles add up to be 180. So these are opposite angles. So 2y minus 3 plus y plus 5 equals 180. And that's how you set it up. Okay, for the other pair of opposite angles here, this is 90, this is 3x. So 3x plus 90 equals 180. It's all for x, all for y. Okay, the last question I want to go over is the last question on your review. So this question was a little abstract, but you can still handle it. Okay, so find the measure of arc BCD. Let's color that in. Sorry, I'm doing this with a stylus on my computer screen, so it's not perfect. Basically, what is that? We don't know. All we know is that the angle BAD is 110 degrees. Okay, so what I'm going to do, it's asking us to find that big arc. When you're doing outies, remember it's the outside arc minus the inside arc divided by 2. I'm going to call this inside arc X. And I'm going to call the outside arc. So if that part is X, if the red arc is X, the whole circle is 360. the blue part is going to be 360 minus x. Okay, so to set this up, that outside angle, which is 110, equals the outside arc, 360 minus x, minus the inside arc, all divided by 2. Okay. So to undo that, you're going to multiply by 2 on both sides. It's going to cancel out over here. We've got 210, 220. When you double 110 is 360 minus x. Subtract 360 on both sides. You get negative 140 equals negative x. Sorry, negative 2x. Divide by negative 2 on both sides, you get x is 70. Okay, so x is 70. It's asking you to find this blue arc. Okay, so that bigger arc is going to be 360 minus 70. So that is going to give you, what is it? 290. Okay, so that arc it's asking for is 290 degrees.